Hello, everybody. I'm Stuart Hameroff, professor of anesthesiology and psychology and director of the Center for Consciousness Studies at the University of Arizona. I've been studying consciousness for many years. I want to first thank the filmmakers, Paul Howard, Peter Rader, Valerie Bishop, David Peet, Jan Wallachek, Bruce Fetzer, the Fetzer Trust for making this wonderful, entertaining, and informative film. The comparisons between quantum physics and consciousness go back roughly 100 years to the origin of quantum mechanics in the measurement problem, the idea that consciousness might be necessary to create reality from the quantum world. Then Schrodinger in the 30s made an analogy between the unity and oneness of quantum physics and the unity and oneness of life itself and then consciousness. Since that time, there have been a number of theories and approaches to quantum mechanics and consciousness comparing the two. We have a wonderful panel today, and I want to introduce our first panelist, Professor Harald Atmanspacher, a philosopher and physicist at ETH Zurich and head of the Mind Matter Society, who also writes the section on quantum approaches to consciousness in the Stanford Encyclopedia of Philosophy. And Harald, among other things, is an expert on the various approaches to quantum physics and consciousness. Harald, how are you?
Thank you, Stuart. Quantum approaches to consciousness. I would say there are three major categories of such approaches which are mainly discussed today. And I call them quantum brain. That's number one. Number two is quantum mind. And the third would be mind and brain, or mind and matter as dual aspects. What does that mean? So on a quantum brain, what we understand is that people usually study consciousness in terms of its brain or its material correlates. And you can, of course, you can do that at many levels. You can look at the brain as a whole, large-scale brain dynamics, brain activity. You can look at more details. You can look into the transport processes at synaptic clefts connecting different neurons, and you can even look into the interior of neurons, where you find structures like microtubuli and so on, and that's, of course, what Stuart is very famous for. The second category is quantum mind, and in quantum mind, people, I should say, try to ignore the brain completely in the first place and try to use the mathematical apparatus of quantum theory to study mental processes, mental activities, like cognition, like perception, like decision-making, attention, and other things. And this is an area in which Thomas Philk, myself, and several others have done some foundational work 20 years ago. So that's the second category. And the third one is that the brain and mind, the physical and the mental, are not studied or are not considered as some kind of basic reality at all, but they are considered as aspects or perspectives, I could say, under which the actual reality can be accessed. And the actual reality, the underlying reality itself, is in this kind of approach is considered as neither mental nor physical. It's something that some people call psychophysically neutral. And David Bohm's work, as far as consciousness is concerned, actually falls into this category. David Bohm's and Basil Hiley's work, and the notion of the implicate order and holo movement and others actually refer exactly to this psychophysically neutral domain. And of course, when you do physics, then you can try to find access to this domain because the explication of the implicate order that should lead us back into something, into all the structures that we know in physics. David Bohm is not the only one. There's another person who has given much emphasis to this idea. This is Bernard Despagnat in Paris. He has coined the notion of veiled reality. instead of implicate order. There's Wolfgang Pauli's approach, and there are also older approaches like Bertrand Russell, William James. They all fall into this category. So we have these three categories: quantum brain, quantum mind, and brain and mind as dual aspects. Stuart.
Thank you, Harald. Our next panelist is Pavo Pilkenin, a philosopher at the University of Helsinki in Finland. Paavo worked with David Bohm when Paavo was younger. In fact, he appeared in a film, in a photograph, walking with Bohm and his wife, and also later in an interview. And he continues to work and collaborate with Basil Hiley, who was also in the film, and was Bohm's great enduring collaborator. Paavo, how are you?
Very well, thank you, and greetings from Helsinki. Yes, I thought I could say a little bit about one idea that was very important for Bohm when I knew him or interacted with him, and that's the idea of active information. And perhaps usually when we think about information, we think of it something that is for us, for human beings. So, for example, information in a newspaper is something that it's for us. But Bohm felt that we could also see information as something that exists in the world, independently of human beings. So, in that sense, it would be a realist view of information. And such information usually is not passive. Now, an example would be, we say that the DNA molecule contains information. And that is, of course, that's not information for us human beings. It's actually information for the cell. It's guiding protein construction and things like that. And we have, of course, similar idea information with pilot control devices and sort of radio controlled devices where the radio waves can be guiding aeroplanes and things like that. And of course, with computers, there's information guiding activities. So for Bohm, one of the radical ideas he had, that he wanted to extend that idea to his interpretation of quantum mechanics. So we saw pictures of this quantum potential in the film, but Bohm also felt that if you look at the mathematics, it's only the form of the waves that determines the effect of this potential. So there's a kind of an informing process in place all the way down. But of course, there's also information in our subjective experience. So when I'm reading a map, there's an information content building up in my mind, and that's guiding my activities. So Bohm felt there was kind of an analogy between the way information operates at all these levels, whether subjective experience, biology, or even quantum physics. And this was, of course, the speculation that maybe, if we say that there's also a sense in which mind can act on matter, or information can act on matter, this might take place through this quantum potential, the active information there. And that, of course, connects also with the ideas of Hameroff and Penrose, because this would require that in the brain there would be some areas, some sites, it could be microtubules, maybe somewhere else, where this quantum potential could actually play one part of the role in which, if you like, mental states influence physical states and vice versa. Back to Stuart.
Thank you, Paavo. Our third, thanks. Our third panelist is Sabine Hossenfelder, a physicist and author from the Franklin Institute of Advanced Studies. Welcome, Sabine.
Hi, everybody. Hello from Germany. I thought I would say a few words about what makes David Bohm so interesting to me. So what makes him interesting to me, and I think to a lot of people, is that he had all this technical background and he knew all the mathematics of quantum mechanics and so on, but he didn't stop there. He ventured beyond it. And of course, this makes a lot of physicists roll their eyes because it necessarily means that some of his ideas don't have the mathematical rigor that physicists are used to today. But I think that Bohm, like no other, understood what quantum mechanics is really trying to tell us. And I mean both the mathematics and the experimental evidence. It's trying to tell us that if you chop up the universe in disconnected boxes and you try to understand what's going on, it will not work. Everything is connected. And if you don't take this into account, then you end up with this mess. That's the interpretations of quantum mechanics today. So you really have to look at the universe as a whole to make sense of it. And of course, this idea that everything is connected also has a spiritual component. And I think that's something that we should not be afraid of, but it's something that we should embrace because it brings the often very abstract mathematics that we use in the foundations of physics much closer to other areas of our lives. And we're only just beginning to understand, I think, what Bohm was talking about. I think he was well ahead of his time. Back to Stuart.
Thank you, Sabine. Yes, non-locality and interconnectedness seems to be a theme in both the quantum physics of the universe and also the brain-mind. Even within the brain, there seems to be interconnectedness that's more than just nerve signaling across. There was a question from Daniel Porofsky, actually several questions, all about comparing Bohm and the philosopher Alfred North Whitehead, who had a process theory that consciousness was a sequence of events, was a process rather than a state. And Paavo, if I may ask, direct this to you, you mentioned in the film that Bohm said that consciousness was like movement, and it's constantly moving, which kind of resonates with me to Whitehead, but also raises the question: moving through what? And could you respond to that?
Yes, okay. Now, as far as I know, Bohm did read Whitehead. I don't remember exactly who mentioned that, but when he was in Bristol, there was a time when he started exploring these new ideas and thinking about this order. He was interacting with an American artist, Charles Biederman. And I think he says in the letter to Biederman that Biederman asked him, is there anybody else who is, developing this kind of ideas of order and structure and process? And then Bohm said, well, Whitehead is the only one he's aware of. So there is a kind of a connection at the very beginning between those approaches. And there are similarities in the sense Bohm has this idea of unfolding and enfolding, and Whitehead has things like concrescence, which are kind of analogous. And there's actually a book called Physics and the Ultimate Significance of Time, where all these things are discussed in some detail. So if somebody would be interested in reading about the relationship, I would refer to that. But I guess other than that, I think when moving to what, I think the idea is that there's for example, Bohm would say that information is a very condensed form of meaning that needs to be unfolded. So there's this constant process of unfolding and then enfolding, which is taking place, and I think that's the sort of nature of that movement.
Thank you. Harald, would you like to comment on that?
Yeah, I'm not sure about that. When Whitehead wrote Process and Reality, which is considered his major work, that was in Pavo, is that right, in 1929 or something like that?
Yeah.
And Whitehead was mainly digesting relativity theory at that time, not so much quantum theory. And I think David Bohm was, in that respect, he was a little ahead of Whitehead, because he really had this notion of non-locality and holism as we have it in quantum mechanics. So my sense is that this additional impact of Bohm's knowledge of quantum mechanics made his process philosophy, or let's say process philosophy, both richer and deeper.
Thank you. We have a question from John Clive, I believe, about the implicate order. Would somebody like to expand upon, Paavo just mentioned it, the implicate and explicate orders and the folding and unfolding? Paavo?
Okay, I can give it a try, and maybe others can add. Of course, Bohm used these various analogies to illustrate what he meant, and maybe the best one is the hologram, where in the holographic plate, each part of the plate contains information about the whole object. So if you have a hologram of a chair, and you break your holographic plate into many pieces, you can still one single piece of it will contain information about the whole. So it's as if the whole is literally enfolded in each part, and that's the hologram illustrates that. But perhaps also a very simple example is that when you are in a room, in every and the lights are on, so in every part of the room there is a movement of light waves, and then that movement at every point again enfolds information about the entire room. And so you put your eye at any region, and then you can unfold that information or explicate it if you like. So these are just simple examples or analogies to give an idea how he felt. But when you apply this to reality, then you're thinking that also in quantum field theory, there's a similar kind of movement of those fields where the fields from all regions come to a single point and then they unfold into the rest. So in a way, every particle also, there's a sense in which it unfolds or implicates the entire universe.
Thank you. Of course, Bohm worked with, pardon me?
Can I add something?
Was that Sabine? Yes, please.
Yeah.
Please.
So I just want to point out, so that there is no confusion, this idea that the universe is a hologram has in the past, say, 2 decades, been very much used by string theorists. But it has a very different meaning. So this idea of the holographic principle that string theorists are talking about in the context of the gauge-gravity duality means that everything that's in our universe can be described by something that's on a lower dimensional surface. Whereas what Paavo was just talking about means that the information about everything is contained in every single part. So these are not the same ideas, even though they're both kind of holographic in a sense.
Must you ascribe to string theory to follow a holographic universe idea, or does it occur in other approaches? Sabine.
Well, so this idea of the holographic principle is somewhat more general than only string theory. It originally comes from black hole physics, but it's certainly been carried forward a lot by string theorists in a very specific mathematic form. I don't personally subscribe to it because if you look at the mathematics, it really only works in a universe with a negative cosmological constant. So these are the so-called anti-de Sitter spaces. And well, for all we currently know, the cosmological constant in our universe is positive, in which case this whole idea doesn't really work.
Thank you. I was going to mention that Bohm worked with Carl Pribram on a holonomic or holographic theory, and I knew Carl and collaborated with him also, and he was criticized because there's no laser in the brain, and of course I suggested microtubules might be the laser. But let's move on to a question from Florian Thalhofer, who asks, what is the plenum? I think Bohm himself in the beginning of the movie, mentions the plenum, which is a term that goes back to the Greek, meaning the void in between matter. Rather than matter moving through a void, there was actually some background pattern. And this debate went on for eons until being settled fairly recently, I think. Harald, would you like to comment on that, please?
Yeah, I'm not familiar with the Greek origin. You say it means the void in Greek, but what I know in Latin, it's curiously just the opposite. It's fullness or totality. But this may actually tell us something, because when you, for instance, when you look into certain techniques of meditation, then what the adepts are advised is to look for emptiness in their thoughts, and once they reach the state of emptiness, this will flip into fullness. It will flip into a kind of experience of a totality. And that's something that, again, relates, in terms of David Bohm's thoughts, I think relates a lot to what he called the holo movement and a very basic implicate order. So a very basic kind of enfoldment. And of course, this has, one can ask the question why Bohm came up with these notions of unfolding and enfolding, implicate order and explicate order. Of course, this has to do with the way in which, in quantum mechanics, wholes decompose into parts. A whole, as it offers itself, as it presents itself, is not consisting of parts, but the parts are unfolding from the whole if you apply certain operations on it. And then what is implicit in the whole becomes explicated in the parts. I think that's a very, very, very interesting way to illustrate where Bohm actually, coming from physics, tried to generalize beyond the limitations of physics into some much broader domain. Stuart.
Thank you, Harald. We have a question from the David Bohm Society for Pavo. You have done wonderful explorations of Bohm's work in the past. Are you currently exploring anything in this area?
Well, that's a good question. We're actually we are writing a article together with Basil Hiley, and there's going to be an anthology on quantum mechanics and consciousness, and so I guess that paper, there'll be some of my recent ideas and then some of Basil's recent ideas. I think Basil's are much more difficult, but also radical than mine. But anyway, we're trying. That's what we've been discussing and trying to understand. And of course, in some ways, actually, Basil's proposals are, well, they're radical in the sense that he is actually suggesting that the Schrödinger approach is not necessarily that fundamental, and that perhaps, in some ways, we have to rethink what we mean by active information. We might have to rethink what we mean by the collapse of the wave function if we follow that road. So that's one aspect, but I guess other than that, there are many exciting projects. There's quite a lot happening at the University of Helsinki. The Academy of Finland recently awarded 5 million euros to a new area called Mind and Matter, where also I think some kind of more like Bohmian themes can be explored, and which we have recently recruited some people there also, and I feel there's a kind of an openness, also interdisciplinary openness, that perhaps hasn't been there before. So I'm quite looking forward to that. And Harald already actually visited us and gave us a bit of an introduction, and we're going to have a conference next year, if one can advertise here. That'll be in June, and where at least Stuart will be there, hopefully, Corona allowing. So we'll see what happens. So, but anyway, there is quite a lot going on. There are also many PhD students starting and postdocs. So there's actually quite a lot of nice things going on.
Thank you. I should add that quantum approaches to consciousness were considered very unlikely for many, many years because of the issue of decoherence and whether quantum biology could occur at warm temperatures. And evidence in the last 10 years has been definitely in favor of functional quantum biology. But I have a question for physicists, and we have two of you. How would a physicist define consciousness? Sabine, you're a physicist. You don't work in consciousness, but from someone outside the field, how would you define it?
Well, it's a difficult question because I'm a particle physicist, so I deal with elementary particles, and it's not that we're at the stage where I can say, okay, look, if you want to have a system that is conscious, the particles need to have these and those interactions. So if you're asking for that level of detail, no one knows. But I do think that in principle, it should be possible to describe relevant aspects of consciousness by way of how information is being acted upon in the brain. And in principle, it's also possible to measure it, basically. So this idea of integrated information theory and related approaches is, I think, a step in the right direction. But what we're seeing right now as ideas of quantifying consciousness for a general system are like, a toddler's first steps. So it's a big progress in a sense, but it gives you no idea what the child is going to be at some point. So roughly speaking, if you extrapolate from what people are doing right now, then consciousness will imply some sort of self-monitoring, basically, of the system. You need some way of acting upon information, but you also need some instance that makes sense of what's going on in the system. I guess that's the best I can do.
Well, that was very good. Thank you. Here's another one for Sabine that's more in your area, if you don't mind, from JJ Flattery. Sabine, could you comment on how the works of Gabor and Bell, Gabor, I guess Dennis Gabor, and John Bell fit into Bohm's implicate and explicate order?
So I have to pass.
Harold?
Okay, can you say again who was that other? Who did?
Well, Gabor, which is holography, and then John Bell. So Bell's inequalities fit into Bohm's implicate and explicate order.
Yeah, but I mean, John Bell didn't talk about implicate and explicate orders, but John Bell actually, in his famous paper in 1964, when he set up the Bell inequalities, he discussed an experimental scenario, which was a refinement of the original Einstein-Podolsky-Rosen scenario, and this refinement was suggested by David Bohm in I don't know, in his textbook, I think in his textbook 1950. So there is a relation already at that point. And then I think the closest Bell got to the implicate order was just by violations of Bell inequalities, because violations of Bell inequalities are the litmus test for non-locality. And non-locality exactly gives us those holes that hold implicate information for something that yet needs to be explicated. So if you, I said that before actually, if you disentangle holes into parts, then you generate, you unfold something which is infolded before, and you generate explicate orders from something that is implicit, has been implicit before. Does that make sense?
Yeah, I think so. Here's a question for Pavo. Actually, this is kind of amalgamation of several questions, but Bohm doesn't include collapse, quantum state reduction, but you've said in some of your papers that I think the folding and unfolding is somehow analogous or achieves the same thing as quantum state reduction or collapse. Would you like to comment on that?
Well, so yes, I think it's actually for the non-physicist, it can be Bohm can be a bit of puzzling, because if you take his book Wholeness and the Implicate Order, it's a collection of articles that came out in 1980. And I think in chapter 4 he discusses the hidden variable model, where you still think of the particle electron as a particle that's moving, and there are these trajectories that we saw in the film. But in a way, with the implicate order approach, you actually give up that notion of a little thingy moving continuously, and you replace it with this unfolding process. And where one way of visualizing it might be to think of that not only is there this wave function that spreads out, like Penrose was saying in the film. There's also the idea that Bohm had that, you see, typically in quantum mechanics is that the wave function will be spreading out, but when you make a measurement, then you will find the electron in a localized small area. And one of the puzzles is, well, how come, what happens there? Is there a collapse of the wave function? So actually, Bohm was thinking that not only is there this outgoing wave, but perhaps there's an incoming wave. And when that wave closes into a point, it gives rise to a particle-like manifestation. So it's not the kind of collapse that you usually talk about in quantum mechanics, but it's still a sort of a process where you are producing particle-like effects from an underlying wave-like process. So in that sense, I think you might see there's something a little bit like a collapse taking place there. Perhaps one could also add that Bohm and Hailey themselves, in the book Undivided Universe, in the later chapters, they also consider modifying quantum theory. Most of the book is trying to discuss ontology within the usual quantum theory, but in the later chapters they look at other approaches, and there they speculate about the possibility that the wave function might collapse to where the physical particle is in their model. So if somebody wants to check that out, I guess that would be one idea to check.
Thank you. Here's a question from Paula Di Florio for the panel. How does the physics community today, rather than then in Bohm's day, react to going outside the scientific construct to get the answers Bohm was looking for? Has anything changed? I would say we're not going outside the scientific construct, but maybe the mainstream scientific construct. But Harald, anybody want to tackle that one? How are we doing in the quantum consciousness?
I can say something. I want to say something about this. Everybody knows the work of Thomas Kuhn, the historian of science. And although we today would say that Thomas Kuhn overstated his case a little bit, but in some respects he was certainly right. If you really want to come up with something fundamentally new, you can't be part of the mainstream. You can't. It requires additional, courage, additional ideas, and whatever. And in that sense, I would say this is a recurrent theme in the history of science. Anytime something really new came up, I mean, really new, I mean not crossword puzzle solving, but some really revolutionary new ideas, you need to be, you are almost automatically a minority.
Yeah.
Maybe I can add
And that's the case today too.
Yeah, thank you. Yeah.
Yes, as to the question, where's physics today? I think part of the reason that we're even here and having this discussion is that the foundations of quantum mechanics are receiving a lot more interest now than 10, 20 years ago. And this has not so much to do with the rethinking, in the psyche of physicists, but it's very much just due to technological progress. There are just so many more experiments that you can do right now that probe the foundations of quantum mechanics that just were not possible in Bohm's days. And with this larger accessibility of the quantum realm that is really pushing the boundaries on so many frontiers. There comes this renewed interest in what does it actually all mean? Did we ever really figure it out? To which the answer is no, basically.
Well, we'll see. Here's another question from Cynthia Sue Larson. She wants to know about the Bohmian dialogue that was mentioned in the film. And Paavo, do you want to tackle that one?
Yeah. Yes. Yes. Well, that's a very interesting, important question, and there wasn't that much in the film about dialogue, and I think it's partly because there were so many topics to be covered, but for Bohm, it's really is an extremely important theme, because I think a lot of his frustrations that we also heard about in the film have to do with problems of communication. Of course, the way his own ideas were received. And, there seems to be some evidence that rather than there had been a real open, good scientific discussion, there was this kind of ignoring and dismissal, which really also means not listening, not really even trying to understand things properly. But there was also this, what we saw in the film was the proposal that Bohr and Einstein failed to communicate, and this also influenced physics a great deal. So that's how Bohm got very interested in he actually tried to approach also problems of physics through dialogue, and asking, well, what would it take for Bohr and Einstein to have a dialogue? And he actually discussed that with Maurice Wilkins, and he was saying that, Bohr and Einstein, they should have tried to understand the other point of view better than their own. Or actually, Bohr should have understood Einstein better than Einstein himself, and vice versa. And this way, perhaps they could have made progress. But I think also in the film there was a lot about Krishnamurti, and how Bohm he really got excited about this, also this possibility of human freedom, and perhaps some kind of an enlightenment through this exploration of the mind and consciousness. But I also, and I was also quite interested in Krishnamurti when I was in my sort of early 20s or so, and I used to talk with Bohm quite a lot. We sort of shared our experiences, both the positive ones and the frustrations. And I also felt, for Bohm, he felt quite strongly that although he admired Krishnamurti in many respects, he also felt that in some ways there wasn't the kind of group dialogue that maybe Bohm felt would be really important and needed. Maybe that was also going back to his old kind of socialist ideals of, rather than having one enlightened person, could we actually have a group that would be more equal, and perhaps in that sense. And that's how he got, in his later years, he really explored this notion of dialogue, and made some great discoveries there. And I think that's actually is one of his greatest contributions, that maybe like his legacy, which could actually really help us to also solve our problems today, which we seem to get more and more every day, actually. So that's just a little bit of an advertisement for dialogue, but I would say it's well worth reflecting that.
Can I add on
Thank
this
you.
a little bit?
Of course, please.
I think I think, if I remember correctly, then Bohm talks about dialogue mostly in his book with David Peat on science, order, and creativity. And in that book, this is interesting because he confronts dialogue with the notion of dialectics. And as we saw in the film, Bohm was very much attached to various versions of dialectics. First of all, Hegel, which is dialectic idealism, or Fichte actually, and then Hegel. And then this turned over into dialectic materialism, like Engels and Marx and these guys. And Bohm became, over the years, he became very frustrated with dialectics, be it idealist or be it materialist, and was looking for something that that liberates the version of thinking that he was up to from rigid dialectic methodology. And that's, in a way, in his own biographical way, the source of his understanding of dialogue. And of course, you're right, Paavo. This also had to do with some failed versions of conversation with other people. Same with intelligence and intellect. This is the other confrontation that he discusses in that book, Science, Order, and Creativity. Intellect being the rigidified or petrified version of intelligence, and the same with dialogue and dialectic. So I think that gives an interesting twist on it, in addition to what you said, Paavo.
Thank you, Harold and Pavo. Here's a question from Jayesh Thakkar. For me, I'll probably pass it to you guys. Are our choices also influenced by quantum potential? In other words, in addition to our awareness? And I'm more familiar with the Penrose approach, in which our choices are indeed influenced by what Roger calls non-computable influences inherent or intrinsic to the universe. So my question to Pavo, I guess, or others would be, does the quantum potential do sort of the same thing and influence our choices?
Well, I think the Bohm never wanted to reduce consciousness or mind to the level of quantum potential. He rather thought that there would be a kind of a hierarchy, a series of levels of these fields. And so our choices would take place at those, I guess you could say, deeper levels. They could be even at the level of implicate order, as Harald has described here. But then I think the quantum potential would maybe more play role in the realization of those choices in the physical world, if you like. It's a bit like a steering wheel for the fields and particles in the brain that then would be amplified and control our movement. So, but I think, you see, because the quantum potential is calculated from the wave function, which in the standard quantum mechanics would obey deterministically the Schrödinger equation. So if you only stay within quantum mechanics itself, within the Bohm theory, you wouldn't get that kind of freedom. You might get that in the Penrose Hameroff idea, where you have a collapse, because then you are breaking the deterministic evolution of the Schrödinger equation.
Thank you. Harold, Sabine, do you want to comment on that one?
Not necessarily.
I guess I would agree. So I guess the brief summary is that if you think Bohmian quantum mechanics is it, then the answer is yes. So the quantum potential also dictates our choices. But I think that's not what Bohm had in mind, at least in his later years. I'm not quite sure where he started from. I seem to remember that originally his intention was to find a deterministic way of satisfying Einstein's idea that God does not play dice, but he seems to have somehow dropped this in his later years. But if you think that Bohmian quantum mechanics is it, then our choices are also determined. Personally, I don't subscribe to this idea.
Can I comment?
Thank you.
Yeah, I would just
Pavo.
say there that, I would just say that already, you see, it's interesting that already in the 50s, if you look at the 52 paper on hidden variables, then that looks pretty deterministic. But already in 1954, Bowman Vigier published this stochastic interpretation, where you are proposing it's partly to try to explain the statistical nature of quantum mechanics. But what they do is to propose a subquantum level that then again has different properties. And in the 1957 book, Causality and Chance, Bohm would propose that there could be actually even deeper levels and even not a fundamental level. And I think that was his way, even then, trying to save the idea of freedom, if you like, that we shouldn't think that reality could be reduced to a single level, either a deterministic single level or an indeterministic level. So I guess you could say that already in the 50s he was perhaps thinking in the framework of dialectical materialism, and trying to develop from there. But it's quite clear that he wasn't attached to the idea of determinism in the way people sometimes accuse him or criticize him.
Thank you. We're running out of time. We had one more question. I don't know if anybody really wants to answer this, but Ray, R-E-I, asks about Bohm and the anthropic cosmological principle. It's a tough one for a short answer. Anybody want to?
Yeah, I've never heard about this connection before, at least not by anybody who I'm talking with, and I have no idea how these could hang together. I mean, the strong anthropic principle means something like, we see the universe as it is because we are, constructed as biological, physiological systems based on, say, the natural, the universal constants and fundamental laws of, I don't know, nature. And that's why we must exactly discover these laws and these constants. But I have no idea how this connects to David Bohm's.
Okay, thanks. I will say that Roger Penrose and I addressed this and offer some kind of explanation. And just for those who don't know, this refers to the fine-tuning problem, the fact that all of the constants in the universe are precisely what they need to be to support life and consciousness. And why that is, it's a gazillion to one shot, but somehow it happens. And it could be that the consciousness is tuning the universe itself as time goes on. But that's a whole nother story. So we've run out of time. I'd like each of you to just make a brief closing comment, and then we'll call it a day. Harald, why don't we start with you, please?
A brief closing comment. Yeah, I would. Paavo mentioned this conference next year in Helsinki, and I think that public money is now really given to this kind of enterprise, mind and matter or mind-matter relations. That's a very good sign. I haven't seen any other public money investment of this size so far in other countries, but we can hope that this will become more like the rule, because I think these questions, and David Bohm was, of course, one of the pioneers looking into this. They are extremely important, not only for scientific progress, but also for environmental issues. There's this whole movement of deep ecology now, which is essentially based on this same ideas. Mind and matter are interconnected, and also societal issues and so on. Alexander Wendt's book, you may know. So we can only hope, and I would rather be optimistic than pessimistic that this goes forward this way. Thanks, Stuart.
Thank you. Yeah, thanks, Harald. Paavo.
Yeah, I guess I'll just first mention that although the Academy of Finland, they gave a lot of money to this area of mind and matter, it's actually the Fetzer Franklin Fund who is funding the conference. So it's another great effort. In a way, I think Fetzer wanted to all support this initiative from Helsinki, and so great. We are really grateful for all that. And I guess I would say about this, I think the film is great in the way it gives a glimpse of these various aspects of Bohm's life, but it's of course necessarily only a partial. And of course that way, and here in some ways, of course, then we are promoting Bohm a lot and maybe making him a bit of a hero, which he kind of deserves. But I think it's equally important to remember that he made many different proposals, often or at least sometimes quite contradictory with each other. He would and I think there's also there's much room for exploration and also like a critical discussion, many different viewpoints here, which really is also this kind of dialogue that he was hoping for. So in all the celebration, I think also we have to realize that the problems are very difficult and there's really a lot of work to do and much to explore. But thank you, everybody.
Thank you, Paavo. I'd like to say also thank you to Fetzer for funding our original Center for Consciousness Studies grant in 1997, which has allowed us to hold the conferences over all these years, and also for sponsoring the Science of Consciousness online conference, which will be in September. And they've really done a tremendous service to the field of consciousness studies. My closing remarks are that within neuroscience, and I deal a lot with neuroscientists, and I think that quantum effects, non-locality, coherence, just within the brain, forget about the universe for a moment, just within the brain, requires non-locality and quantum coherence for the unity and the coherence that we see in even things we can measure. So with that, again, I want to thank the filmmakers, the Fetzer organization, Bruce Fetzer, and Peter Thader and Paul Howard for making this wonderful film, and Valerie Bishop for promoting it, and Paavo, Sabine, and Harald. Thank you so much for what I thought was a very interesting discussion. And thank you all for listening and watching, and stay conscious.
And Sabine is still okay.